testing tomorrow and he's gonna say,
What
you're
does
gonna walk
Kenny say?
there.
Wow, your life goal is to finish that in algebra
Yeah.
too. Yeah, you're doing pretty good.
Almost there.
It's actually kind of cool, like these leads, yeah.
I'm trying to get the kind of like the circle thing, so.
Yeah.
What's on the back of this? Are you gonna do that side too?
Yes.
Very good. We will grade when they come back. So we're going to jump to 6.5, equations containing radicals. So you have a radical equation. So equations containing radicals. If I gave you y is equal to 2x plus 4, okay, that is not a radical equation. Okay. If I gave you an equation y equals root 2x plus 4, also not a radical equation. And the reason is that the variable is not underneath the radical. So in this case, root 2 is just the slope.
Oh.
So it would be 1.41 over 1. So it has a slope of root 2. So this is not a radical equation. The same way if I said y equals 1/2 x plus 4, that's not a rational equation. Because just because it has a fraction doesn't make it a rational equation. What would make it a rational equation is if you had 2 over x plus 4. Now it's a rational equation. Why? Because x is in the denominator. So the fraction part entails the variable. So to make something a radical equation, right, you would have something like this, square root of x plus 4. Now you have a radical equation. Why? Because the variable is underneath the radical. So when you go to solve radical equations, now these ones with the y involved, you're not solving that. That would just be an equation that you could graph and go from there. But when you go to solve radical equations, like what we're going to do, is you're either going to square or cube, depending, right? If you have like the cube root of x plus 4, you wouldn't square it to get rid of the radical. But radical equations, that's when you square it or cube it or whatever you might do to get rid of the radical and solve. So let's do some equations. When you square both sides of an equation, though, I'll give this one to try. When you square both sides of an equation, you can come up with what we call an extraneous root, meaning extraneous is extra. So you can, it doesn't mean you always do, but you can come up with an extra root that does not work. Okay, and the reason for that is that when you square it, I'm trying to think of an example for you. If I have this equation right here, and I said, actually, let me think about this. I'm just trying to think if I can come up with one. Let's try this. If this was the equation, okay, square root of x is equal to x. If you square, actually though, that may actually end up working. Because if you square both sides, you get x is equal to x squared. I'm laughing because I'm going to subtract the x and we have to factor.
Isn't x just equal to 1?
So x would equal to 0 and 1. X equals 0 and 1, which the original equation was square root of x is equal to x, 0, 0, 1, 1. That one works. So you actually don't end up with an extraneous root there. We'll do an example. I'll find an example that we come up with an extra root. So you can, though, come up with an extra root, and in which case you should check your answers when you finish solving, check them and make sure they work. Okay? So that one didn't work out for us to find an extra root. Actually, both of those roots work by solving. So let's go ahead and solve some formal ones, and I'll discuss what I'm doing there. I just cruised through it, and then it didn't work out how I wanted to because I wanted to come up with an extra root. All right, so if you have, let's start with this. Square root of 3n plus 1 is equal to 7. So the square root of 3n plus 1 is equal to 7. So you know it's a radical equation because the variable is underneath the radical. So you just need to get rid of the radical and then get the variable by itself. So how do I get rid of a square root? By doing what to both sides? Square both sides, right? So we're going to square both sides, and you would end up with 3n plus 1 is equal to 49. Now when you square both sides, you don't do plus or minus. That's only when you take the square root of both sides. So if you're squaring both sides, you would just go like this. Subtract the 1 over, 3n is equal to 48. And n is equal to? 16. Now, it would be worth plugging in and checking, and you plug that back in. 3n, 3 times 16 is 48. 48 plus 1 is 49. Square root of 49 is 7. 7 is equal to 7. So that one's pretty straightforward because you have a radical by itself equal to a value. Square both sides and go from there. Obviously, they're going to get a little more, there's a little bit more work to some of them. If you have, let's go with square root of 5y squared plus 1. This isn't necessarily a lot more work, but it adds this component of the y squared on the inside. Some people make an error, they take the square root of the y squared and they just get rid of it. But you can't do that because you have a 5y squared plus the 1 with addition in there. So again, if I isolate, now I didn't mention this on this one, but isolate the radical, make sure the radical is by itself, which it is, then square both sides. So if anything was attached to it, you'd want to try to isolate it first. So square both sides. When you square both sides, what are you left with? 81. Subtract the 1 over. Now you're just solving a basic quadratic equation. The nice thing is there's no factoring involved here because it's not a y squared plus a y, it's just a y squared, so it's a perfect square one. Before you take the square root, we need to divide by 5, and we end up with 16. Y is equal to plus or minus 4. Now you wanted to check and make sure both answers work. And when we do that, you'll notice that if you plug in a 4 or a negative 4, it's going to get squared. So, in other words, a negative 4 squared is going to be positive, and the 4 squared is going to be positive. So you end up with 5 times 16. 16 times 5 is 80. 80 plus 1 is 9. 80 plus 1 is 81. Square root of 81 is 9. 9 is equal to 9. So that one works out for us just fine. Yes. Okay, so now let's do this one. 5 plus a plus 7 equals a. So 5 plus square root of a plus 7 is equal to a. So now you have the variable underneath the radical and you have the variable outside of the radical. So it's going to take a couple different steps to get there. If you can, isolate the radical, then square both sides. So it is possible to isolate the radical by getting rid of the 5, right? And then we have a plus root 7 is equal to, square root of a plus 7 is equal to a minus 5. See, if you don't get rid of the 5 and you try to square both sides, you would have to square this entire binomial and then FOIL with the radical part, which is doable, and we'll have to do one of those, but it's a lot more laborious, which we all know is spelled E-O-U-S. Okay, so a plus 7 equals a minus 5. Now at this stage, right, we're going to do what to both sides? Square both sides, right? So we're going to square both sides. We get a plus 7 is equal to a minus 5 quantity squared. And then you have to FOIL, yes, very good. So a plus 7 is equal to a squared minus 10a plus 25. Okay, so mental foiling. If you're not up to speed on your foiling, just FOIL it out and you'll be fine, you'll get there. Now, this looks like a polynomial equation. 3 steps to solving a polynomial equation with factoring. Step 1, set it equal to 0. So you have 0 equals a squared minus 11a minus 18 plus 18. What?
Minus 9 minus a plus a minus 9 a minus 2.
Yes, thank you, because I messed it up with saying minus 18, but it's plus 18.
So how do we know it's just a minus 9, a minus 2? I don't understand.
What times what gives you 18 added together gives you 11, 9, and 2? So a is equal to 9 and positive 2. So you plug that back in and you double check it. If you plug in a 9, 9 and 7 is 16. Square root of 16 is 4. 4 plus 5 is 9. 9 is equal to 9. Check. Plug in a 2. 2 and 7 is 9. Square root of 9 is 3. 3 plus 5 is 8. Does 8 equal 2?
Nope.
No.
It's only 9.
So 2 doesn't work, right? So it would just be 9. So there you have an extraneous root, Miles.
So why would the 2 not work?
Well, if you plug in 2, right, and 2.
Is there a reason it doesn't plug in? Because if we got it out, shouldn't it go back in?
I know it's an extraneous root because when you're squaring both sides of an equation, you can come up, you're adding like an additional root.
Oh, okay.
Because if you have just an equation, that's what I was trying to show one over there, and it didn't work out for me, which is unfortunate.
There were some other equations in the past that had like extra things attached to them and that they didn't work.
Yeah, I'm trying to think of like a basic one. Well, here's one for us. Let's do this. Here's an equation. X equals 4. Okay. Now, whatever you do to one side, you have to do to the other, right? So, but we know the original equation I'm working with is x equals 4. So what do we know the only thing x equals? 4. So if you take this and you say x is equal to 4, and let's say we add 10 to both sides, you would have x plus 10 is equal to 14. That's fine. Go backwards, what do you get? X is equal to 4. But, and you knew that right from the get-go. Let's say you have, we'll keep going with this. Let's say you have, with the same thing, we know that x equals 4 is the original. So whenever we come back to it, we know x has to only equal 4. So we have x is equal to 4. Let's say you divide both sides by 5. So you have x over 5 is equal to 4 over 5. Okay, so now go ahead and solve that going backwards. You say, okay, multiply both sides by 5, right? And the 5's cancel, and you're going to end up with x is equal to 4, okay? And so you say x is equal to 4. Now, let's go ahead and square both sides. X squared is equal to 4 squared, so x squared is equal to 16, right? Now, if this is what you're looking at, I know that I can plug in a 4, or what else could I plug in to make this true? Negative 4, right? But if you go back up here, can you plug in a negative 4? No. So when you square both sides, you add a root because x squared means there's 2 answers in there. And so when you square both sides, you potentially add an extra answer. Not always, but you potentially do.
Okay.
So, yeah, so here we don't see it as clear why 2 ends up being an extra root, but it can be extra. Here, it worked out that both answers do work. So that's why you have to plug in and check.
Okay.
What are you doing? Oh, nice. That is using force.
The force. Okay, now it's going to say on these next ones, a radical equation or linear equation are given. Okay, and it says solve radical equation by squaring both sides, solve a linear without squaring both sides. So you're going to tell you a linear equation is given. We'll do part A here and then part B here, just so you see. And your 2 equations, you're going to be given this, 3 root x is equal to 12. Okay, and then you have x root 3 is equal to 12. So you have A and B. Which one is the radical equation? A or B? As you're writing it down, which one's the radical equation? A, because the variable is underneath the radical. Which one's your linear equation? B. Now linear means it forms a line, right? And if I said, this is a little review, if I said graph for me x is equal to 7 on an xy plane, what kind of graph does x equals 7 give you?
Vertical.
A vertical line at where? 7. There's 7, it's a vertical line through 7, right? So if I said graph for me x equals root 2,
Would be in between
1.4ish, right? So here's 1, here's 2, and it's somewhere in between, like that. There you go. If I said graph for me, x is equal to negative 5 over root 11. How would you graph that one?
Simplify it?
Well, sure. Get your calculator out and find the decimal and graph it. So what does negative 5 over root 11 give you in decimal form so we can easily graph it?
Or decimal.
Yeah, because you don't want to graph 5 root 11 over 11. Where's your calculator?
Negative 1.5.
Negative 1.5, approximately, right? Okay, so negative 1.5, approximately, and you graph the vertical line. So the same is true here, right? Is that when I go to solve for x, how would I solve for x on part b here?
Can you divide by the root of 3?
Sure.
Where do you square it?
Why would you square it? X is by itself. Meaning there's just a root 3 attached to it. You could square it. It's not wrong. Whatever you do one side, you have to do the other. But if you square it, you have to square the x as well, right? You'd have to go that squared, distribute that in, so you get x squared times 3, and then you're going to have to do what in the end to get rid of the squared part? Take the square root, right? So, and then you'll have plus or minus, so you'll be adding a root like we just showed. So when it's not a radical equation, there's no reason to square it, as you don't need to get rid of the square root. So you divide both sides by root 3. Then this you'd want to put in simplest radical form like this, and so x is equal to 4 root 3. And that's all you have to do. You don't have to graph it. So then you have x equals 4 root 3, which would be a vertical line at 4 root 3. So that's how you do a linear one. Don't square it. Pro tip. When it's a radical equation, first step is isolate the radical. So you have the square root of x is equal to 4. And then you square both sides. X is equal to 16. And you plug it back in. You get x equal to 16. So the square root of 16 is 4. 4 times 3 is 12. 12 is equal to 12. There you go. So when you go to solve a radical equation, you will end up squaring both sides, or cubing, depending. In this case, it's square root. All the ones we've been doing are square root. When it's a linear, non-radical equation, don't square both sides. You could, but then you're actually going to end up with extra roots in this case, and it's just extra work. So if x is no radical involved, don't square it. Okay, so now we got to go and do a challenging one. Oh boy. The challenging one is what happens when you have, we're just going to jump to the granddaddy of them all.
Oh, what?
Ish.
Second granddad.
His second granddad.
Multiple variables?
Multiple radicals with variables underneath. So you're going to end up doing some foiling with radicals. 5y minus 1 minus square root of 7y plus 9 is equal to 2. Okay. So the issue with this is that the easy route, which would be the wrong route, is just to square the left-hand side and get rid of both radicals. Like square this, and be done with it. The issue with that is that's wrong because it's attached with subtraction, so you'd have to square the whole thing. Typically, if you can, get one of the radicals by itself, then square both sides, because then at least you're getting rid of one of the radicals on one of the sides. So probably easiest would be to add this one over, so you're left with 5y minus 1 equals 2 plus 7y plus 9. Now it doesn't matter the order, you could have done 7y plus 9 first and then the 2, it doesn't matter. So now when you have the 5y minus 1, now you can square both sides. When you do that, you're going to end up with 5y minus 1 is equal to the 2 plus root 7y plus 9 squared. Okay. The issue with this is that you have to FOIL this. Now this one you could mentally FOIL, but I'll show you the longhand FOIL just so we see it a little bit, how it works. 5y minus 1 is equal to 2 7y plus 9 times 2 root 7y plus 9, like that. Okay, so I heard somebody say what? 4 plus, and we can maybe do a little bit of mental math. Oh, this is 2 plus, I'm sorry, I didn't put plus there, 2 plus there. Alright, so here you're going to have 2 times root 7y plus 9, and then this is going to be same thing, 2 times root 7y plus 9. So how many root 7y plus 9 do you have? 4 root 7y plus 9 is in there. Plus, and then those multiply together, the radicals are going to cancel. Yep, 7y plus 9. So, once we get that, the issue is that I have a radical still. So now I got to go, again, isolate the radical, and then square it one more time. So we go to isolate the radical, we're going to bring this 4 and this 9 together. That's 13. You're going to subtract it from both sides, so you end up with negative 14. Then you subtract the 7y. What do you end up with? Negative 2y is equal to 4 root 7y plus 9. Isolate the radical by
Dividing 4.
I divide by 4. When you divide by 4, right, those are going to cancel. Divide this by 4, those are going to cancel. So you're going to end up with a I'm trying to think, do you want the pro tip?
Pro tip.
We don't love the negative there. I mean, because we're going to end up foiling. Okay. So you can factor a negative out. So you'd end up with this. You're going to end up with a y minus 7 all over 2. I'm sorry, y plus 7 all over 2. Now, where did I get that from? Well, I take the negative and bring it out front, right? So if you distribute the negative back in, you get a negative y and you get a negative 7. So that gives us our negative. 2, 2, and 2 cancel out with everything. So, now, the reason why that's a pro tip is, okay, when we go to square both sides, since that negative is attached with multiplication, we can square the negative and it becomes a positive. So that'll be really nice because then it makes the math a little easier. You're not missing as many little things with the negative. Okay, so we come back. Now we got to jettison this problem up here. It looks a little complicated with fractional work. However, when you square both sides, so I have a negative y plus 7, right, over 2 is equal to square root of 7y plus 9. And you're going to square both sides. When you square both sides, the right-hand side has the 7y plus 9, so that part's easy for us. The nice thing is you don't have to worry about like foiling the tops and the bottom, you know, as like a fraction times a fraction and doing this like weird foiling with that. You can remember this exponent can go here and to here and out to there because that's division and multiplication. What you can't do is you can't take the 2 into the 7 and the y. But what you can do is say the negative becomes a positive, the top is y plus 7 squared, and the bottom is just 4. 2 squared is 4. Then what I would do is I'd just get rid of the 4, bring it to the other side, so you would end up with 28y plus the 36. Now this, again, the math isn't that hard, it's just laborious. It's a very labor-intensive problem, right? And a lot of room for error. Lots of room for error. So, you know, it's a challenging algebra, not because it's complex, because we're doing all basic steps that we've learned. Oh, square both sides. Okay, I know how to do that. Foil, we know how to foil. A negative squared is a positive. We know how to do that. But when you add it all together, there's lots of rooms for error. So here we end up with, foil that out, right? Y squared plus how many y's? 14. 14 y's plus 49. You set the equation equal to 0.
Very quietly.
Did I do my math right?
No,
No?
I don't think it factors. It'd be
14
26.
I'm sorry, negative 14y, right? I didn't. That was looking a little bit off. Subtract 28 from both sides. 14 minus 20 is negative 14, right? So that part's right. 49 minus 36 is 13. That part's right.
So it's y minus 13, y minus 1.
Okay, y minus 13, y minus 1. There we go. So y is equal to 1 and 13. Woo!
Yeah, plug in both those and see if they're right.
Is this like calculus or?
No, well, it's, this would be, I mean, this problem wouldn't be, the specific problem isn't in calculus, but this is the type of problem that you'd end up with pretty consistently in calculus. Is the math isn't extreme, but it's the steps. It just, and then you become weary and then you just give up.
I don't think one.
That's what I do. If I got this on my homework, I'd probably get halfway through it and then just
Yeah. Usually don't end up, I mean, I shouldn't say this, but don't end up putting some of these on like a test because there's so many problems asked. And this problem, the expectation is would take you probably at least 5 minutes, you know, working step by step. It takes time, 5 to 10 minutes, and it's not necessarily what I want to test on.
Oh, it takes me 5 minutes to do a problem, so.
just multiply that by 2 and you get 10 minutes.
Yeah, we'll go on this.
So plug in 1, you get out 2 here, right? Plug in 1, you get out 4. 2 minus 4 is negative 2. Does that match 2?
Nuh-uh.
Nope, so 1 doesn't work. Plug in 13, you get out 65 minus 1 is 64. Square root of 64 is 8. 7 times 13 is 91. 91, is it 91?
Negative 91. No, wait.
No, it's just 9.
What? Yeah.
Oh, 10.
7 times
It comes up to 10.
13 is 91. 91 plus 9 is
100.
100. Square root of 100 is 10. 8 minus 10 is negative 2. Do either work?
No.
What the heck?
Oh
So this is what happens. So I'll do that,
Go through
right?
all
And then
that
I'll
work
think,
for
oh,
no
it can't be no solution. So I'll redo the problem wrong.
Okay,
Then
so
I'll
the
get
this
another
problem
one
is
answer.
no solution.
Which
Is it
doubles the
really no
length of the
solution,
problem.
or do we
This
do-
problem just turned
It's
into
no
a
solution.
20-minute problem.
Blasted.
I drew an angry face next to my name just to let you know how mad I am.
At least we have like the satisfaction of knowing that people watching the video will get to the like keep working it down and then all of a sudden, ha
It's the
ha!
most unsatisfying game in the world. No solution.
I'm like, wait, why are we supposed
Is
to
it
do this?
actually-
Why is this not working?
Are you sure it's no solution?
I'm sure.
It's so convoluted, it makes you question yourself.
So there's no number you can plug in that'll make that true.
Darn it.
Seriously.
Because whatever you plug in on the left-hand side will be smaller than the right-hand side.
Oh.
No matter what number you plug in. And if you plug in negatives, then you're going to be taking the square root of negatives and getting out imaginary numbers.
Was there a guessing and checking thing you could have done to get that or not?
You could have tried to logically think through and say, will this square root ever yield something that's larger than this square root?
Could you always do that?
Well, logic is killed in geometry, so.
Yeah, you could try working that out, but like on a, again, this one probably won't end up on like a test or a check. That's why it takes too much time.
Or I'm just gonna look at it and put no solution.
Yeah, just put no solution.
And then he's gonna ask for work to be